Hello, welcome to this video. This is 5-4 Anti-Differentiation Indefinite Integrals. And in this video, we're going to talk about a huge idea in calculus, and that is integration. Right over my shoulder here, integration. And this is the symbol for an integral, and we'll kind of talk about that in this lesson. I'm going to split it up into two videos. The first one will just talk about indefinite integrals, and then the second video will focus on position, velocity, and acceleration examples. All right, so without further ado, let's go ahead and look at some warm-up examples. Pause the video right now. I want you to just really quickly calculate the derivative of these functions. All right, hopefully you've had a chance to go ahead and differentiate each of the following. So here we're going to go ahead and calculate f prime. So f prime of x is equal to 3x squared. Here, if I calculate f prime of x, this is also 3x squared. The derivative constant drops off. And then here, if I have a constant value, f prime of x is going to be 3x squared. So it doesn't matter what that constant is. And what you should notice is that all of these derivatives are 3x squared. Okay, so what do we get when we anti-differentiate f prime of x equals 3x squared? So anti-derivative is kind of going backwards. Well, whatever we're always going to get is x cubed plus c plus a constant, okay? Now, the antiderivative, and here is this term here, anti-differentiation, is known as the same thing as integration, okay? And it can be written just like this. Okay, and we have this symbol here, okay, which is called an integral. I want you to say that with me, integral. Okay, good job. Okay, so, and that tells you to integrate or anti-differentiate. Note, that expression is called the integrand, okay? dx indicates that we are integrating with respect to the variable x. So you'll notice that we always have a dx whenever we are taking the integral of an integrand, okay? And it's just telling you you're going to integrate with respect to that variable. Okay, c is called the constant of integration and must be written as part of your answer when you are anti-differentiating. So you'll see some of this here in our integration rules. We have a power rule for an integral. Okay, we have a power rule when we differentiate. We have a power rule when we integrate. Okay, and what the power rule says is that you are going to add the power, so increase the power by 1, and then you'll divide by your new power. Okay, and this makes sense because when we differentiate, we drop the power by 1 and we multiply. Well, to go backwards, you have to do the inverse or the opposite of that. Okay, and then you'll always have c tacked on at the end. Okay, so again, plus c. I'm going to highlight this because this is a common theme and this is a common mistake for students. The constant rule. If you have a integrand that's k and you're differentiating with respect to x, the integral of that constant is kx plus c. So again, I'll just highlight plus c. Scalar multiple rule, if you have a multiplier in your integrand, you can factor that out, and then you can multiply that in after you integrate. Okay, and note here, you can never, ever, 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 ever factor out a variable. Don't do it, okay? And then lastly, the sum rule, we will use this a lot. What this is saying is if you're going to integrate a sum, so two items that are being added or subtracted, okay, you can split those apart. So you can integrate them in their own pieces, okay? So let's go ahead, let's apply some of these rules here. And the first integral that we're gonna look at here, we have the integral of x cubed dx. This is just highlighting the power rule. So what I wanna do is I'm going to raise the power by 1, so that's x to the 4th. And then I'm going to divide by that new power. So divided by 4, and then we add c, okay? And that's it. Number 5, this is highlighting the constant rule. Notice I'm integrating just 2. 2 dx, right? So I want to integrate 2 with respect to x. Okay, so this is going to be 2x plus c. Okay, so simple enough. And then number 6 is highlighting the sum rule. And if I go ahead and do this, I can rewrite this as the integral of t to the power of 4 dt plus the integral of 2 dt. Okay, and this gives us t to the 5th divided by 5 plus 2t, okay, plus c. So again, notice that all of my answers, right, all of these indefinite integrals have a c tacked on at the end. They have some sort of constant, right? If I was to differentiate this, constant would disappear. Okay, you must include the plus c. All right. The next examples that we're going to look at are slightly more tricky. Okay, we're gonna start to get pretty gnarly here. I'm not going to lie to you. Okay, so let's look at number 7. Okay, here I have the integral of 2y squared plus 4y plus 1 dy. So I can go ahead and integrate each of these pieces. Okay, so I have 2y cubed over 3 plus 4y squared over 2 plus y, okay, plus c. And what I want to do is I want to go ahead and simplify this. Let's make this look more pretty. Plus 2y squared plus y plus c. Pardon if you can hear the drum line. I played the drums in high school. I love it. But I'm sorry. I'm sorry if you can't stand the drums. I have no control of the band outside my window. Okay, example 8. Note, I want to go ahead and integrate this, but this looks pretty gnarly, right? Pretty radical. Do you see the radical? Okay, whatever. Let me rewrite this first. So I'm just going to rewrite this integral to be 3 times x to the power of negative 2 minus x to the power of negative 1/2 dx. So now, again, I'm just using my negative exponent property and rewriting my radicals in rational exponent form. So now that I can use the power rule more simply, okay? So this is 3, okay? And then I'm going to raise the power. So I go from negative 2 to negative 1, and then I divide by that new power. So divided by negative 1. Okay, the next example, or sorry, the next piece of this is minus x, okay, and again, negative 1/2, I'm adding 1, I'm going up, okay, so that's going to be a positive 1/2, and I'm going to divide by 1/2. All right, and I'm not going to forget the c. So what I want to do is I want to go ahead and simplify this. So this is negative 3x to the negative 1st. And actually, we really don't like the negatives, but I mean, I'm going to write it as over x, right? That's over x to the 1st, okay? Minus 2 square root of x plus c. So this would be the simplified form, okay? All right, and then number 9. Number 9, what I'm going to do, I'm going to split the denominator. So I'll rewrite this as the integral of the square root of x over x squared plus 1 over x squared dx. Okay, and I'll go ahead and rewrite this. So this is x to the power of negative 3/2 plus x to the power of negative 2 dx. And if you're confused how I got the negative 3/2, we have x to the power of 1/2 divided by x to the power of 2, so that's this property here, right? So 1/2 minus 2 gives us negative 3/2, x to the negative 3/2. All right, so now we want to go ahead, we want to integrate this. Okay, so I'll raise my power by 1, so I have x to the power of negative 1/2 divided by -1/2 plus x to the power of -1 divided by -1, and we will get our answer. Okay, so this gives us -2x to the power of -1/2 minus 1/x plus c. I almost forgot my plus c, but I didn't. All right. Okay, so there is some anti-differentiation integration with indefinite integrals, okay? And it says note here, always put a plus c when you integrate, never when you differentiate. I never really made that mistake, but maybe you will, okay? Just note. So when we integrate, we always add c, not when we differentiate. Sometimes these problems, they will give you an initial condition, okay? And initial conditions are kind of fun if you like problem solving. But what you do is they're going to give you an indefinite integral, and then they'll give you an initial condition to help you solve for c, okay? So example 10, they say if f prime of x is equal to x to the power of -3, and f of 1 equals 3/2, then find f of x. Okay, so what we want to do, they give me f prime, so I need to integrate to find f of x. Okay, let me switch colors here. So f of x, if I integrate this, is going to be x to the power of -2 over -2 plus c. Okay, or rewritten, it is going to be 1 over 2x squared plus c. So there's my function f of x. Now what they do say is they say that f of 1 is equal to 3/2. Okay, so f of 1 is equal to 3/2. Okay, so I'm gonna take my function f of x and I'm just gonna go ahead and plug in 1. Okay, so I have 3/2 is equal to 1/2. Oh, you know what? I forgot a negative. This is negative. So that is negative. Okay, plus c. All right, so what I want to do is I want to go ahead and solve for c. I have this equation here. 3/2 is equal to -1/2 plus c. Now, if I want to solve for c, I'm going to add 1/2 to each side, add 1/2. And 3/2 plus 1/2 tells us that c is equal to 4. Okay, so if, 4 over 2. So if c is 4 over 2, which is 2, and this is my function, then here is f of x. F of x is equal to 1 over 2x squared plus 2. There's your function. All right, that is initial condition. Very, very cool, very, very interesting. The last thing I want to talk about, this one's kind of like a basic problem, but we will see these situations. So in 11, they say evaluate d dx of the integral of 5 times root x minus 1 over x squared dx. So I'm taking the derivative of an integral, okay? And when you get this, what happens is they just cancel each other out, right? They're inverses, they undo each other. Okay, so this answer would be 5 root x minus 1 over x squared. And that's your answer. I hope you love that band. All right, this is where I stop. I'm going to go ahead. I'm going to split this video. The next video, we will talk about position, velocity, acceleration. Catch you next time. Peace.